Welcome back to this SQL course. So now we are going to see the decimal numbers or float numbers. These are also common ways to call these types of columns. We are going to see here. I'm going to describe again our Sakila.film table. Let's go and check it. So there's a need for storing numbers that are not only integer numbers such as 1, 2, 3, 4, 5 and so on. There's a need, for example, to store 1.5, 1.7 in several databases. An example would be where you have prices for specific goods. So most goods don't cost a simple €1. They cost 1.30 cents or €1.30 or $1.30. And you need to have those decimal points so that you are able to store the number and not have it rounded in databases. It would be extremely difficult to work with databases if they only enabled integer numbers. So there's data types that will help us. Let's discover them in this lecture. We have, for example, here the rental rate. Now see this decimal that we have right here, decimal 42. These numbers are relevant for the decimal data type. Not so for the tiny int or small int data types. They are not that relevant for those, but here they are because they are reflecting how these numbers stored in the database. So the 4 that we have right here is normally called the P, precision. So this is the amount of numbers that you will have, is the amount of digits that you will have in your floating or decimal column. And the 2 means the number of digits after the comma, after the decimal point or after the dot. No matter how you represent the decimal point, it means after that decimal point. So in this case, the rental rate will have 4 digits and will have 2 digits on the left of the decimal point, 2 digits on the right on the decimal point, because we have a precision of 4 and we will have 2 digits on the right. Okay, so this is our first introduction to data types and we'll explore them when we are creating our own tables. Don't get too confused by this, just important that you understand the difference between what's an integer, what's a decimal. And here on the decimal we have then these two numbers, P and also D. For P, the number of total digits that we have on the number, D, the number of digits that from those total digits will be on the right side of the decimal point. Okay, so if I go to my Sakila, for example, here on the Sakila, if I select everything from the Sakila.film, as we will see, I'm going to run this, you will notice that we will have here on these rental rates, we have, in this case, we'll have 4 digits, but most of them don't have 4 digits because most rental rates are 0.99, 4.99. But now notice we always have 2 digits after the decimal point that we see right here in this decimal number. Okay, that's because we've defined it in this way when we've created this table and we gave that data type. Here in the replacement cost, it also should be, I don't think there's anything here with more than 4 digits because we have 1, 2, 3, 4. I think this is also a decimal for 2. If we check the describe in the replacement cost, let's see it. Let me hide here the output log and replacement cost. It's actually 5.2. There might be movies that have 3 digits on the left. Okay, here on this table, it is enabled by the data type that we have right here that we have those numbers. So if we have 290.99, that's enabled in this column because we have right here this decimal 5.2 and that is relevant. So we'll do more experiments with data types when we create our own tables. Okay, when we are creating our own data, don't worry about it. The decimals are then to represent numbers with, of course, decimal points. But I can do for mathematical calculations also with these columns. For example, I have here the rental rate. If I do select rental rates and rental rate times 4 from Sakila.film and run this one, I'll have a numeric calculation applied just the same as I've done in the small int or integer types that we've seen before. So there's no null like we've had when we applied some type of calculation to the title that is a character column. If I try to do a logarithm also here, logarithm of the rental rate, and try to run it, we'll also be able to apply that calculation to the column that we have right here. Okay, so you also have numeric as a data type, which is quite equivalent to decimal. They do almost the same thing. There's no relevant difference between decimal and numeric. And you also have another data type, which is the float data type. It's less precise than the ones that we are doing here with decimal and numeric, but it's faster to do calculations on. If you are not worried about super tiny decimal points in the calculations that you are doing on your table, you can use float because the calculations that you will apply on that column will be faster. But if you are worried on those super tiny fractions that may cause trouble in calculations, then refer to decimal or numeric. For example, for accounting purposes, for numbers that represent money and accounting purposes, you have to have a numeric or a decimal data type, because the tiny fractions that may fail in the precision with the float may cause a lot of troubles to financial systems. So it's required that you have the highest precision possible when storing the number in the database. Okay, so this is a really important data type, not only the decimals that we see here, but also the integers that we've seen before. On these columns, we can apply mathematical calculations. We've seen different characteristics of these data types. For example, the question of the precision. How many numbers can we store, or how many digits can we store in a single number? We've approached them here. This is supposed to be the first light approach to data types, because when we are going to work in the next section with our own tables and creating our own tables, we'll be doing much more experiments with these data types. I just think that it's better to approach data types first and getting to know what are the differences between numeric and text columns, and then only experiment with these data types at the same time that we are creating tables, so that we can work around with our own data and not trying to do something on the Sequila database, because this is just a toy database. It's not something that we are creating, so it makes sense for us to experiment further down the line. This further down the line is just in the next section, where we are going to work in creating our own data. Okay, we've seen numeric columns, mostly integers and decimals. Next, we are going to see another common type of data types, which is the text data. That's really commonly used throughout databases, as we will see, and I'll see you in the next lecture.